Okay. No, I think we can start now, don't you think? Level off, great.
Yeah.
Okay, fantastic. So I'd like to say hello and good morning. My name is Dan Loughlin, and along with Noah Kittner, we're the session chairs for the Air, Climate, and Energy session today. And we're very excited to have, so far, nearly 100 people attending this session. That's great. So let's see. And Noah, can you go to the next slide? For our session today, we have 14 panelists, and each panelist will summarize their key messages in 1 or 2 minutes, and then answer a pre-submitted question. The total time for each panelist is limited to no more than 5 minutes, and if there's time left at the end, we'll take questions from the audience. As we go through, if you do have questions that you'd like to add to the queue, you're welcome to type those into the chat box, but we'll address those at the end after all the presenters have presented. Next slide. So as we look at the presentations in this session, there were really 4 themes that emerged, and so we've organized the presentations along those themes. Include climate impacts and interactions, downscaling, technology assessment, and management. And so we'll go through the panelists by theme. Next slide. So the first theme, climate impacts and interactions, and next slide. Our first speaker is Yusef, Alizade, Govarchin, Ghale, and he's from Istanbul Technical University in Turkey.
Hello, everybody. Thank you very much. Our study is related to the impacts of Urmia Lake desiccation on the air quality change in the northwestern Iran. In this study, we used MODIS-derived aerosol optical depth data and ground-level PM10 data to investigate the impacts of drying up of Urmia Lake on aerosol concentration in the northwestern Iran. Also, we used 2 statistical methods, including multiple linear regression model and linear mixed effect model to predict PM10 data using aerosol optical depth data and meteorological variables. Our study and our results indicated that the eastern part of the lake is more polluted than western part, as a result of extension of salinization and desertification in the eastern part and dominated wind direction from west to the east. Moreover, the linear mixed effect model performed better than multiple linear regression model to predict PM10 change in the study area. Our next future plan is using CMAS to investigate dust transportation and air pollution in the northwestern Iran and neighboring countries as a result of drying up of Urmia Lake. Okay. Let's start with answer to the questions. Okay, about the first question, as you know, the albedo change affect the top of atmospheric reflectance values and it impacts on the AOD change. The dried bottom of the lake includes 2 main land cover types, naming salt body and salt soil body. As you know, the bright surface, such as salt body, has higher albedo in compared to dark surface, such as water body. And as I told before, the albedo change affect the top of atmospheric reflectance and it impacts on AOD change. The albedo uncertainties resulted in retrieved aerosol optical depth errors. And as you know, same aerosols behaves differently when superimposed to different land cover types. And absorbing aerosols such as dust minerals can be retrieved more accurately in bright surfaces and the results will be more accurate. About the second questions, let me tell you that I have been studying on this lake for more than 10 years. And we have published just 2 papers regarding the main factors behind the drying up of Urmia Lake. According to the results of our studies, the anthropogenic factors, especially agricultural development in the basin, accounts for about 80% of the drying up of Urmia Lake. And the climatic factors, especially decrease in precipitation and increase in temperature, account for about 20% of the drying up of Urmia Lake. If you let me, I can share my screen with you and show the land use change in the study area, then you can understand better, I think. Yes. Here in this slide, you can see the land use change and land cover change in the study area. As you see, the water surface area of the lake decreased over the past decades and the irrigated lands increased in all parts of the basin. In this figure, you can see the land cover change in the basin. As you see, the water surface area has decreased over the past decades and the irrigated areas has increased over the past decades. The area of irrigated lands increased more than 400% in the last decades. And there are more than 50 dams in the basin and more than 100,000 dip wells and semi-dip wells to develop irrigated lands. If you have any question, I will be happy to answer. Thank you very much.
Great, thank you very much, Yusef. We can move to the next. We can move to the next slide. Perfect. Our next presenter is Jia Zheng from the University of Houston.
Yes, my name is Jia Zheng, a graduate student at University of Houston. My study is about the impact of sea fog on air quality with the direct effect of aerosol. The type of sea fog that I examined was the advection fog, which occurs when warm continental air flows over cold sea surface and forms temperature inversion layers. The inclusion of the direct effect of aerosol enhanced the strength of sea fog by increasing temperature gradient, which helps to trap moisture. On air quality, we found notable changes on air quality because the impact of sea fog as a source or sink of gases and aerosol concentrations, and much broader regions were affected than we expected. The direct effect of aerosol increased the changes in the impact of sea fog on air quality. For the questions, that's a great question because, as I mentioned earlier, the formation mechanism of the sea fog is like when warm continental air flows over cold sea surface, and we were curious how the strength of sea fog would change if we consider the direct effect of aerosol, which stabilize the atmospheric condition. Regarding the indirect effect of aerosol, we actually have started working on it. We think that would be interesting to see because over the reason there are a lot of aerosol that can act as CCN.
Great, thank you very much, Jia. And we're going to move on to our next speaker, Daniel Schuch of Northeastern University. Daniel, looks like you're muted.
Sorry, guys, are you hearing me? Hello, everyone. My name is Daniel Schuch. I'm working as postdoc at Northwestern University. In this work, I'm using a numerical model, the WRF-Chem, with a climate scenario, the RCP 4.5, to predict the ozone concentration over Brazil. In this work, I'm using projection of emissions for 3 different scenarios, the current legislation scenario, a mitigation scenario, and a maximum passive reduction scenario. There's a scenario with maximum reduction of emissions, and the main findings of this work is the response of ozone is non-linear from changes on emissions. The spatial patterns of the changes of ozone concentrations is linked to emissions from big urban centers like São Paulo, Rio de Janeiro, and cities from the Northeast region. The maximum passive reduction scenario is a scenario with the better improvement of the air quality, but the mitigation scenario have a better improvement of air quality in the metropolitan area of São Paulo and metropolitan area of Rio de Janeiro. So the question is why does the mitigation scenario have lower VOC emissions and greater reduction of ozone in metropolitan areas? So the reductions of ozone in metropolitan areas for 2030 for mitigation scenario is stronger, the maximum passive reduction scenario, because the combinations of the reductions of VOCs, the volatile organic compounds, and the nitrogen oxide emissions on these regions. This is results from the MIT is similar from the CLE, the current legislation scenario, for this year, the 2030. In particular, in these urban centers, we have a significant reduction of NOx emissions, in particular from the vehicular emissions, which potentially reduce the ozone concentrations in a bigger area. But in very close to the emissions, for example, the metropolitan area of São Paulo, we have a reduction of some process like nocturnal titration of ozone. So this process is weaker. So we have a weak destruction of ozone on nighttime. The second part of the question, this is caused by the non-linearity of the chemistry, or the scenario not intended to be the cleaner emission scenario. This is caused, of course, because of the non-linearity of the ozone formation in the system, but also because of the time of the reactions. This is a classical scenario when you have the ozone concentrations far from the emissions. You don't have the maximum of ozone concentration emissions. So the maximum passive scenario is a scenario with the reduction of emissions, exchanging technologies. So, for example, the VOCs emissions are not the lowest emissions, but other pollutants are very lower for the scenario. So, in a quick note, in special for this high resolution domain, this is a 36-kilometer domain and a 90-kilometer domain, but my emissions have 55 kilometers of resolution. So to improve this results for metropolitan areas, we probably need a better resolution of emissions. I don't know if you guys have more questions. Let me know.
Great, thank you very much, Daniel. We're going to move on to our next speaker, which is Ana Paula Stein Santos from the Federal University of Santa Catarina in Brazil.
Hello, good morning, everyone. Can you hear me?
Yes.
Hello, I am Ana Paula Stein Santos. I am PhD student in the Environmental Engineer program from the Federal University of Santa Catarina. For this conference, we brought the work titled "The Role of Mariculture in Methane in carbon dioxide emissions." We started researching this topic because it's a pioneer area, especially in South America. And with the potential increase of the implementation of aquaculture areas, the assessment of this activity impact is essential for the sustainability growth. The keywords of our work, key points, sorry, is the lack of the mariculture impact in the emissions of greenhouse gases. And they can even act as a carbon sink from carbon dioxide, for example. Few monitored parameters have no difference between control areas and mushroom areas, showing no impact resulting for the activity in the study area. And all the parameters showed environmental health levels, indicating no impact in the water quality also. In this way, we can classify the mushroom culture as a low environmental impact activity for our study area, sure, and as an alternative of low impact animal source of protein. About the questions, you premise that mushroom culture be a more sustainable food source and very interesting. What barriers to greatly enhancing the mushroom farming exist? Are the healthy issues related to the water pollution? Let me see. The mushroom farming is growing faster, really faster, and I believe that the barriers are especially the way of production that needs to be implemented in the sea area, so have a difficult way to develop the activity. Are the health issues related to the water pollution? I think I didn't understand the last question.
And I think you may have answered that in your summary of your key points as well. So I think appreciate your answering those questions, and thank you very much for your presentation. So we'll move on to the next category now, which is downscaling. And if we can go to the next slide. Our first presenter in this area is Surendra Kunwar of the University of North Carolina at Chapel Hill.
Hi, my name is Surendra Kunwar, and I am a PhD student at the Department of Environmental Sciences and Engineering at UNC Chapel Hill. So for this project, we're investigating how climate change would impact PM 2.5 levels in 2050s, especially when considering the effect of climate variability. So we use a global chemistry climate model, GFTL-AM3, to provide boundary conditions to the regional climate model WRF, which dynamically downscales the meteorology from GFTL-AM3. And we also use CMAC, the newest version CMAC v5.3.2 to simulate air chemistry. We actually downscale the chemistry from GFTL-AM3 to the continental US at 12 kilometer level. Eventually, we want to find the probability distribution of mean annual 2.5 PM 2.5, which shows the difference between future and present, and then we want to continue that analysis to human health and visibility as well. So for the submitted question you see here on the screen, it is true that GFTL, which is a little older compared to the newest CMAC version, has different emissions. It actually has 2005 emissions in its simulations. By the way, for this project, the simulations have been kept at present day levels to see the only effect, the effect of climate change on PM 2.5. And for CMAC, we're actually using NEI 2016 emissions, and that's because we want to use emissions that would represent present day levels more accurately, and NEI 2016 is pretty new. It's possible that the difference in emissions will result in different PM 2.5 levels for different regions of the US, but this is work in progress, and we'll see how CMAX simulates present day and future emissions of PM 2.5, levels of PM 2.5. And once that's done, we'll get to see how different CMAC and GFTL. But CMAC uses boundary conditions from GFTL, and its selected years for CMAC simulations are also done based on high PM 2.5 and medium PM 2.5 levels in GFTL simulation of century. And I think there was a question that popped up.
I think we're going to have to wait until we get through all this with the panelists.
Right.
Oh, right.
We'll wait till the end.
Sounds great. Thank you.
Thanks.
Our next speaker is Megan Mallard, who is a scientist at the US EPA, also on the topic of downscaling.
Hi there, good morning. I'd like to share this study where we've looked at phonological changes across the US from dynamically downscale projections, with phonological changes being the changes that we expect in plants and animals in response to seasonal changes. So in these runs, we've used work to dynamically downscale two different global climate models, the CESM, as well as the GFDL CM3 model, under two different representative concentration pathways, both for a historical and future period from 2025 to 2100. And we've looked at two different phonological indicators. First of all, chilling units, which is used to quantify the period of dormancy, which is the growing season for plants and fruit trees, as well as the extended spring index, which is the date that plants experience leaf out and then first bloom, and it applies for a variety of plant species. So our results show that by the end of the century, we expect chilling unit reductions in parts of the southern US, which, just to give some scale to these changes, apple and peach trees usually need around 500 to 1,000 chilling units in order to have a productive growing season. And we see in our runs chilling unit reductions of over 1,000 in parts of the southern US as certain areas warm out of the preferred temperature range for the plants to complete dormancy. Meanwhile, in the northern US, we have increases of between 500 to 1,500 units as some cooler parts of the US warm up into a more favorable range of temperatures. On the other hand, with the spring indices that I mentioned, we see a consistent signal of spring advancement. That is a reduction in the spring index of between 10 to 35 days as averaged over the contiguous US, which is in good agreement with previous studies and tended to be a greater spring advancement in the runs where we downscaled the GFDL model. However, I would like to note that some of the end of century changes that I've talked about here were not found to exceed the simulation's mean absolute error as quantified over the historical period. This wasn't as much of a concern with chilling units, which tended to be where the model's changes tended to be larger than the model's error over the historical period, but it was more of a concern with the consistent positive biases that we found in spring onset as quantified in the spring index, which leads nicely into the submitted question I see here, where the question concerns the bias correction that we could possibly use in light of the biases in chilling units and spring onset over the historical period. That is definitely an interesting suggestion, especially given the large positive biases in the spring index, in order to to look at these runs in context with reduced error over the historical period. However, we do have a plan to develop 12-kilometer continental U.S. runs as opposed to the 36-kilometer ones that I'm presenting here, and to have those available over a similar time period out into future periods. So we're hopeful that with these newer runs, we could update our model version from the currently used one here, which is 3.4.1, to a more up-to-date version of WRF and use more up-to-date physics. And that, along with a higher resolution, might decrease our error over the historical period for these indices and lead to a more robust analysis of changes in the future. And thank you for the question.
Great, thank you, Megan. We're going to switch over to the topic of technology assessment, and I believe, Noah, you're going to take over the MC.
Thanks. Yeah, so our next presenter is Timothy Glotfelty from UNC Chapel Hill, talking about representing the impact of residential energy choice and land use change on future air quality and climate in case of sub-Saharan Africa.
Thank you very much. So I'm Tim Glotfelty, and I'm a postdoc at the University of North Carolina, Chapel Hill. And my presentation focused on using the WRF Chem model to understand the current and future impacts of land use and residential energy choice on the climate and air quality of sub-Saharan Africa. This was kind of a methodological presentation that focused on the four major kind of obstacles that we found to accomplish this application. The first was that the land surface models in WRF do not accurately represent the land surface properties of sub-Saharan Africa. So we had to rework the CLM land surface model to accomplish that goal. And that work is currently in a GMD discussion paper if you're interested. The second part of the project was to harmonize changes in land use and land cover to the offline data sets that WRF-Chem uses for natural emissions, so the dust emission scheme and the Megan VOC emission scheme. So we've had to use kind of a reclassification algorithm to make sure that they sync up with our changes in land use category so that we're adequately representing the impact on natural emissions. Kind of the third task is we needed an emission inventory to adequately account for residential energy use in sub-Saharan Africa. The best available one for this was the DICE Africa emission inventory that's available from NCAR, but that's only provided for 2 years, 2006 and 2013. So we had to expand it outward and generate it for our 17-year case. And then the last part is we wanted to project future emission scenarios based on African residential energy use. So we developed 3 different scenarios: a business as usual scenario, one in which residential energy transitions more towards electricity, and one in which it transitions more towards liquefied petroleum gas or LPG. And so to do that, we had to use the GCAM model to make a consistent future scenario projection. And kind of the overall takeaway messages from this presentation is that it's not straightforward to apply WRF-Chem or some of these other publicly available climate and meteorological and chemistry models for land use, land cover change applications. And this is especially true whenever you're applying them outside the Northern Hemisphere. And for the submitted question, they're asking if we had thought about linking GCAM's land use projections to our method, and that is possible. We had thought about it. The land use modeling method that we're using is a model called Dynamic Ego, and it works by kind of training off of observed land use changes. So we wanted to work with that primarily since it's based on what's actually happening for right now. But we have thought about linking it to how GCAM does land use. And I'll thank you guys for the time and the opportunity, and anybody can contact me if they have any questions.
Thank you. Our next presenter is Daniel Cohen from Rice University with air quality benefits of replacing coal with wind and solar in Texas.
Thanks, Noah. So when it comes to electricity generation, everything really is bigger in Texas. We burn more coal, we burn more natural gas, we have more wind turbines, and we also emit more CO2, more SO2, and more NOx than the power plants in any other state. And so realizing what a big electricity market Texas has been the motivation for a few studies that we've done. We had published a paper a few years ago led by Brian Strassert, who showed many hundreds of premature deaths caused by the emissions from coal power plants, especially the SO2 going and forming ammonium sulfate. We had separately done a study led by Joannis Lucerowicz looking at how wind and solar can be complementary with each other at different times. And so if you could show the next slide. And what we did in this study was we looked at the proposals that are out there. And what a lot of people don't realize is even though renewables are growing fast, there's this interconnection queue of proposed projects that is just absolutely ginormous. There are 108 wind projects proposed and 262 solar projects proposed. And what we wanted to know is that enough? If we just built what's already in the queue without adding any new projects, would that be enough to replace coal? And we did a scenario, we said, what if you allowed 10% of the coal load to be a gap and you replaced the other 90%? And you might have surpluses at other times, but are we gonna leave behind many gaps? And we did mixed integer optimization, and we found that if you go back to the slide, that all it would take would be to build about a fifth of the wind farms that were shown on the previous slide and build 3/4 of the wind farms and build those solar farms in the western part of the state. Those would be enough. You could mix together their output and with a manageable cost, be able to completely zero out the coal in the state. And we did the optimization using 3 years of baseline meteorology and using 2019 coal output. And so on the next slide, we show that this is what would result if you completely zeroed out all of the coal plants that give us 20% of the electricity in the state today. You added those optimized solar plants in the orange, and you added the new wind plants in the light blue, then you would end up with a supply curve that would look like the black line. So you would actually end up with surplus at most times, and you would end up just with a small missing gap around 7 or 8 p.m. is when most of the gap would happen. It would mostly happen in September. So actually not the most problematic months, not when peak demand occurs. And the questions, all three of the questions really, I think, hit on what I expect will be questions that will come up when we submit this paper to peer review, was the mismatch of years. And that was something that was inevitable because we had base years when our meteorology was available, but many of the biggest coal plants closed in 2018. So 2019 is the only year that we have with our new normal of coal generation before the COVID pandemic hit. And but what we have looked at is we've looked at each of those 3 years. The nice thing is that one of those years was the worst drought in Texas history. The other two were more normal rainfall levels. And when we redo the optimization, leaving any 1 year out, we find that we still get nearly 90% coverage, 10% gap as was intended. The last question asked about whether there's a problem with severe events. And I would posit the opposite, that when we've had severe events, there have been coal piles have frozen on the coldest days, the coal piles have gotten too wet on the wettest days. So by moving towards this wind and solar, we would actually have a more balanced supply that would be more resilient to events that might happen. Thank you.
Thank you. Yeah, the next presenter is Michael McKinnon from UC Irvine on assessment of the air quality and health impacts of fuel cell electrification of port activities at a major port complex. And I'm not sure if Michael is here.
I don't see him on the presenter list.
Okay. So we'll move on to the next topic, which is management. Thanks. So we have Sadia Afrin from NC State University with the air quality trade-offs of wildfire and prescribed burning.
Thank you. Hi, I'm Sadia Afrin. I'm a PhD candidate at North Carolina State University. So in these presentations, we talk about that we came up with an unique approach to investigate the air quality trade-off between wildfire and prescribed fire smoke for a specific case study of Western North Carolina. Here, we do that by simulating different historical and hypothetical scenarios of prescribed fire and wildfires. For the calculations of the fire emission, we use the blue sky pipeline, and we simulated the air quality using a 4x4 kilometer CMAS simulations. So initially, we started our analysis by simulating the air quality impact of 2 Western North Carolina wildfires, and then taking the advantage of our CMAS modeling framework, we created some hypothetical prescribed fire scenario, which is needed to treat the total area burned by those 2 wildfires. Then from the consumptions, to reflect the effect of this prescribed fire treatment, we reduce the amount of fuel consumed by those prescribed fires and initiate a third scenario to reflect the after fire impact, which we are calling the post-treatment wildfires. So basically, we are assessing the trade-off by comparing the reduced air quality impact from the wildfire because of those prescribed fire treatment by comparing with their prescribed fire impact. And from our case-specific results, we can conclude that air quality benefit of prescribed fires are higher than air quality impact. And we also notice that the more peoples are being benefited by the reduction of this wildfire pollution because of prescribed fire treatment. So that's some of the results I found. And now to answer the questions I got that how I could modify this method. So in terms of the applicability of the method, I would say that you can apply this method for any region, but you might need more specific fuel bait and other informations to replicate that regions. Before concluding to a national scale conclusions on the importance of prescribed fire, I would replicate this, our approach for different ecoregion of the nations, because the conclusion might vary depending on the fuel beds and the fuel availability, and also for depending on the other factors. But you can definitely apply this same approach for any part. Yeah, I hope I can answer the question.
Thank you. Our next presenter is Calvin Arter from UNC-Chapel Hill on on-road sector emissions impact on PM 2.5 and ozone-related health risks in the Northeast and Mid-Atlantic US.
Great, thanks Noah. So in this study, we present a transportation-specific modeling platform utilizing CMAS version 5.2 with the decoupled direct method to estimate the impact of on-road vehicular emissions from 5 vehicle classes on both PM 2.5 and ozone concentrations for 12 states and DC, as well as 4 large metropolitan statistical areas in the Northeast and Mid-Atlantic US. This study is actually a part of an independent co-benefit study known as TREC that looks to quantify potential health outcomes associated with a range of cap and invest scenarios under the Transportation and Climate Initiative in the region, which is known as the TCI. It's just one part of the TREC study that aims to quantify the air quality and subsequent health-related impacts of on-road vehicle classes in each of the states that make up the region, as well as each state's impact on other states. So some high takeaways from this is, in the region we found that light-duty trucks are responsible for the most PM 2.5 attributable premature mortalities at around 1,200, with 46% and 26% of those mortalities coming from directly emitted particulate matter and ammonia, respectively. While ozone attributable mortalities we found to be around 1,100, with 80% of those coming from NOx emissions. We calculated the full source receptor matrix for on-road vehicular impacts for each of our vehicle classes and source regions. We also monetized the total damages per ton by each vehicle class for all sources and receptors. And we found that the largest single damages per ton estimate is approximately $4 million in 2016 US dollars per ton of directly emitted particulate matter in the New York, Newark, Jersey City MSA from buses in that same MSA. With regards to the question, we did find that vehicular ammonia emissions may be rather important in forming PM2.5 in a heavily populated, largely urban region due to the fast reactions with nitric and sulfuric acids to form nitrate and sulfate aerosols. We found ammonia to be the second largest contributor behind directly emitted particulate matter to PM2.5 attributable mortalities in the region, with the magnitudes of impact being pretty close for those coming from light duty automobiles and trucks. And with regards to the questions per ton estimates, the full question actually references the Deducci et al. Study that had found that reducing 1 teragram of ammonia emissions from road transportations is actually about 20 times greater in terms of damages reductions than a 1 teragram reduction of NOx from that same sector in the US. And we found that in our region, reducing 1 ton of ammonia emissions from light duty trucks is approximately 75 times higher than reducing a ton from that same vehicle class of NOx. And if we compare to one of the more recent EPA's benefit per ton estimates, the Wolf et al. Study in 2019, they monetized PM2.5 damages per ton of directly emitted PM2.5, SO2, and NOx by different vehicle classes broken down by fuel types. And they found the same trend as we do in that NOx actually has the lowest damages per ton and directly emitted particulate matter has the largest. And while they didn't look at ammonia explicitly, we can say across these 3 studies, including ours, that the message remains that the importance of on-road emissions of both directly emitted particulate matter and ammonia in terms of their impact on both absolute air quality impacts and a per ton emitted basis remain very important. So if you have any additional questions, feel free to reach out to me. Thank you.
Thank you. The next speaker is Funky Jia from the US EPA, using marginal abatement cost curves to identify optimal control strategies for meeting state-level NOx abatement targets.
Thank you, Noah. So in this project, we look at different control strategies for states to meet their NOx emission reduction targets and develop the state-level marginal abatement cost curves to assess the cost effectiveness of various control measures using GCAM USA model. So by observing the dynamics of measure components in an optimal control strategy, which is traced out by the marginal abatement cost curves, we found that non-traditional measures such as applying renewable energy and fuel switching are cost competitive with many traditional measures, such as applying the end-of-pipe control devices. Also, such non-traditional measures can increase the potential of NOx reduction comparing to applying traditional measures only. And last but not least, the components of an optimal control strategy, or say the optimal mixture of traditional and non-traditional measures for NOx emission reductions can be differed by states and the reduction targets. So the pre-submitted question here is which non-traditional control measure was most effective across states at reducing NOx emissions? So one of our major observations from the results is that the optimal strategy components are varied by states and the reduction targets, especially for each state has a different energy and technology profile at the reference scenario. The application or say the penetration of non-traditional measures in a cost-effective control strategy can be different among states and different at reduction targets. So one of the examples here is that some states might have just introduced the renewable energy in their air quality management plan. So the renewable energy could be potentially cost-effective to use in achieving their NOx reduction targets in the early stage. Well, for some other states might have applied renewable energy for a while. So for them, a cost-effective strategy might address more on improving energy efficiency for the current technologies to reduce more NOx emissions. And one more note here is that an optimal strategy in this project really contains multiple measures, considering both traditional and non-traditional controls, instead of applying one certain control measure only. However, we did observe a lot of fuel switching and price-induced demand changes as non-traditional measures in an optimal strategy for many states. But in terms of the most effective control measure, it still depends on specific states. their current energy profiles, and their specific air quality goals. Thanks for the question.
Thank you. The next presenter is Paulina DiStefano from the US EPA, a method for identifying challenges to air quality management and developing robust management strategies.
Thank you, Noah. My name is Paulina DiStefano, and I'm an ORISE Fellow at EPA's Office of Research and Development. And my presentation outlined an ongoing project, really a fairly nascent project that we've been working on to identify emerging challenges to air quality management and greenhouse gas mitigation in response to some input we've received from state air agencies about what research questions would be of interest to them. Given some of the deep uncertainties that we're expecting in some of these longer time horizons, this project is modeling a set of about 8 different dimensions, including things such as socioeconomics, technology availability, different policies like energy and transportation policies, in a full factorial design using GCAM USA. We'll be looking to identify some of the common dimensions across our high emission scenarios in order to identify those emerging challenges that we're looking for. We'll also be looking for scenarios that have low air pollutant and greenhouse gas emissions to understand what sort of sets of policies or kind of background conditions that can support multi-pollutant reduction aims. We do expect to generate some interesting results from this analysis, but also large scenario sets and high dimensional data can be tricky to interpret, which I think leads to this question. Because this endeavor can also be kind of hard for states to replicate given the computational and data management logistics of a project of this size. So while we're still exploring our plan for dissemination of data beyond avenues such as journal publication, our decisions around dissemination will have a big influence on how we're able to present results intelligibly. So I do think that there are some ways that we can represent all of our 8 dimensions with some visualizations like parallel axes graphs that are really well suited for high dimensional data. But I think in other types of visualizations, like the ones that I included in my presentation, we'll need to find ways to reduce the dimensionality, probably sticking to about 4 dimensions as I had in the visualizations that I presented. So tools like regression trees can help us identify what are the most important factors, and we can base visualizations off of those. Or we can hold some of those factors constant, like if socioeconomics is continually the most important, we can hold that constant and then dive deeper into some of these other factors and dimensions. But ultimately, I'm hoping that if we get enough interest, we can look into using a dashboard tool so users could drill down into data based on their own focus on the dimensions that they find relevant, and perhaps isolate a few preferred baselines based on the state and focus on policy impacts, which is what we found that states are primarily interested in, policy impacts. So thank you for the question, and I'm happy to chat with anyone over email if anyone has any other questions or comments.
Thank you. The next presenter is Dan Loughlin from the US EPA on the GLIMPS project, a decision support tool for air quality management.
Thank you, Noah. Can we go ahead and go to the next slide? Perfect. So, GLIMPS is a decision support tool that we're developing at the EPA that is built around the GCAM model. You've heard a couple other speakers mention the GCAM model. GCAM is a human Earth systems model that includes representations of the energy, agriculture, land use, economic, water, and building systems. And the model simulates the co-evolution of those systems through time, including how they're the dependencies and interactions between systems. So what GLIMPS does is it sort of builds a graphical interface and framework around that model that facilitate users exploring different scenarios and evaluating the impacts on different endpoints. So the kind of things people can look at are different assumptions about population growth or resources or climate change or technologies, and look at the impacts of those on technology choices or fuel prices or greenhouse gas emissions or air pollutant emissions and other endpoints as well. So, so this is a system that we've primarily been using in-house at EPA for different applications and research, but we are exploring how GLIMPS could support state-level applications, and that's been the focus of of a lot of our work in the last year, and that is the focus of the presentation. Noah, can you go to the next slide? So there's a lot of text that I added to the bottom here. Well, the question was, how truly reliable are modeling tools of this kind, since they don't appear to take into account socio-political factors? For example, when artificial price increases on goods and services would be larger than what the people living in the region or state are willing to tolerate. So I think this is a really astute question, and it was kind of thought-provoking as well. And I have an example that I was providing from Frankie Jaw's presentation, but I think I'm just going to, for timing, stick with the text on the right. So GCAM can provide some useful information when it comes to basically prices on goods and services and fuels in response to different policies. And so, for example, you can see from the model things like changes in the price of electricity or changes in demand, so the amount of VMT or heating requirements. And so sometimes those changes can be unreasonable, but you can potentially look at that and see where those changes occur, and it can provide insights about where there might be those intolerable impacts. And it might also provide some insights regarding where perhaps the model needs additional technology or other options added to it. So for example, if the transportation sector is responding to a climate policy by shutting down the freight industry, heavy duty freight, and that's an indication that maybe that sector, we should kind of relook at the technologies represented there, and so it can be a really useful tool for even understanding like the model and how it works. So we're developing some post-processing tools also that would allow you to, when you look at the results of a particular run, sort of automate the process of looking through the demands for goods and services and understand and highlight the ones that are changing the most, so that we can kind of bring that to the surface for additional investigation. So really great question. So I think I'm taking maybe control back from Noah, and we're going to go through some of the questions that have been submitted. And there have been a number of those that have been submitted. Some it looks like are being answered as we go. And so I'm going to try to get some that haven't been answered yet. So let's see. So this is a question for Kunwar. How much of the PM 2.5 developed in mid-century is due to wind-blown dust and sea salt primary aerosols and biogenic secondary aerosols developed by different meteorology versus anthropogenic SOA from the consistent anthropogenic emissions? Does the ratio of these two categories change over time? And I do wonder, Kunwar, if you can see that question, because I don't think I did a very good job of reading it.
Hi, thanks, Dan. So I typed the answer in the chat.
Oh, did you? Okay.
Or actually the type answer, using the type answer function of Q&A widget, but I can quickly say that, we have kept the anthropogenic emissions constant, and we let the natural emissions to evolve with meteorology. So we will expect changes, but because this is an ongoing work and I don't have the simulations completed yet, what the magnitude of that evolving ratio of anthropogenic SOA and natural SOA is from now to the future. So hopefully in a future talk I will have that.
Great. All right. Thank you, Kunwar. So as I look at the questions, it looks like most have been answered. There's one to me that hasn't been answered. If people would like to submit more questions, please feel free to do that. So the question to me was, can GCAM GLIMPS offer sector-specific emissions growth decline estimates within a state for use as a specific future year emissions inventory input to a photochemical model? So the answer to that question is yes. So basically the way that we would do that is for a particular source category and and pollutant species at the state level, we would do essentially generate an emissions growth and control factor that would translate our value from a year that was similar to an emissions inventory out to a future year like 2035 or 2050. And so we can generate those source category and pollutant and state-specific factors, and we've mapped those to SECs so they can use in smoke to modify a future inventory. So, answer is yes. Do we have other questions that have not been answered? Okay. I'm not seeing any right now. So as we wait, I do want to take just a second and thank all the presenters for their excellent work with their presentations. And I hope that if you haven't had a chance to see the presentations from this session, that the Q&A session has kind of piqued your interest, and you'll find those presentations and watch them, because I feel like a lot of good time and effort went into these, and they're nice jobs by the presenters.
Yeah, I also just wanted to echo my thanks to the presenters for really interesting discussions and the audience for insightful questions.
So I guess we do have a couple more minutes, and more questions can come in. I do have a couple that I could fill a little bit of time with. So one is for Dan Cohan, and the question is related to your modeling was showing that there was surplus electricity being generated. And so I'm curious about how the surplus electricity would factor into the sort of the economics of your optimization models choices. So for example, would that take into account the fact that there's a lower capacity factor on those potentially like wind turbines, and so their levelized cost might be higher?
Yeah, so we defined our optimization as what is the cheapest way to build out enough wind and solar farms that you could replace 90% of coal. We meant 90%, meaning that you only leave 10% of gaps left over that have to be filled by something else, such as natural gas. But yeah, in getting to 90%, we had surpluses. And the really nice thing about this is that the surpluses come most strongly in the middle of the day in summer, when we actually get more solar generation than the coal that's being replaced. So we're actually generating more high value electricity at those times of peak demand. And when we do have some gaps, is mostly on September evenings around 8 p.m. and there's usually plenty of slack in the system. So both a lot of coal damages that could be avoided and a lot of valuable surplus summer, midday, and afternoon power that would be generated by this subset that was picked.
Great. Thanks, Dan. Okay, well, I think we have reached noon, and I don't know if the conference representatives on the call have any housekeeping to do, or if we can call a wraps on this session. So, Brian or Soraya? Well, I think, we're good?
Good, Dan. Thank you very much. Wonderful session, and we'll take a break and reconvene for the next session.
Sounds great. All right. Thank you, everybody, for participating.
Thank you.